Hello students. In the last session we have discussed about the integrator and the differentiator. Those two are the very important applications of an operational amplifiers as practical as well as theory. I'm going to give one example on that differentiator. You have to try it for your integrator in your home. I'm going to give the same equation. You have to solve it in the integration also. You have to solve it. You can get it very easily. This kind of questions they may ask for your examinations. As a last time, I'm going to yes, I'm going to explain about this session. Right. Only solve. I'm going to solve the only one equation, one problem. In the further, if you are not getting that one, if you refer the Ramakant Gaikwad book, Op-amp operational amplifier, that is very important for your exams. Also, you can get the very good notes from there, and you can see that when whatever I have covered the notes from that referred by that author, I'm going to refer that one. Everyone they are referring that op-amp for that book, and you are also going to refer that book, and I'm going to give the notes also, and I'm going to give the some problems for your homework. You have to solve it and send it back to me, and that is also very important for that one. Now I'm going to explain about the only one example I took that from differentiator. Design the differentiator. We simply input signal that varies in the frequencies. If you have seen that one, if you have seen that, watch that videos, you have to see that one. The different frequencies from 10 hertz to about the 1 kilohertz. If sine wave of the 1 volt peak at the 1 kilohertz is applied to the differentiator of the part, draw its output waveform and C1 equals to zero point 0.1 microfarad. What they can ask for that one, peak in the sine wave, cos wave will come. Differentiation. Correct. Cos wave will come. You have to draw the waveform as well as you have to find out the circuit. You have to draw the circuit. These things you have to do that. You have to draw the circuit. You have to draw the waveforms. Just they have given the values. I'm going to give that's why I'm going to give the one example for that one. What kind of questions they may ask for that your exams. Solution. F equals to 1 divided by RFC1. Yumne RF equals to 1.59 kilohertz. How it comes like that? I'm going to solve that one. F equals to 1 divided by 2 pi. RF, don't know that one. C1 0.1 microfarad. Correct? F value is they have given. How much they have given it is 1 kilohertz. 1 kilohertz. What is the capacitor value it is? It is a zero point 0.1 into 10 raised to minus 6. 10 raised to minus 6. It is a 10 raised to plus 3 and minus 3. It goes to the numerator. It is a plus 3. Correct? 10,000 divided by how much it is? 2 into pi into 0.1. Yes, minus 1 it goes to the here, it is a 10,000. 10,000 divided by 2 pi. How much you can 10 divided by 2 pi? It is in the kilo. 6.28. 10 divided by 6.28, around you can get it 1.59 kilo ohms. Yes, F equals to 1 divided by R1 C1. Instead of RF, R1 C1. FA and FB. Two frequencies are there. Higher frequency and the lower frequency. FC is a cutoff frequency. Correct. 2 pi R1 C1. C1 value you knew about this one. 2 pi you knew about this one. F is new about this one. And you have to put these values. R1 equals to 1 divided by 6.28 2 pi. 6.28. C1 is 0.1 into 10 raised to minus 6. F is how much they have given that one? R1 C1. Right? Frequency value FB. FB is around it's 6.28 1.1. Here you have to take that one 2 pi. FB is around yes, FB they have not given is here. FB equals to 20 kilohertz. They have not mentioned in this here. If you are take that one FB, yes, this is a FB and this one is a FA. FB equals to 1 divided by 6.284 1 divided by 6.284 into 2 into kilohertz, it is in the 4 20 10 raised to minus 7 micro 0.1 into minus 7 minus 7 plus 4, it is a plus 3 1000 comes there. 1000 divided by 2 into 6.284. If you are calculating like that, you can get the 79.5 ohm. You have to get it 79.5 ohms. You have get it there, and R1 equals to 79.5. Then by your equation, CF equals to R1 C1 divided by RF. If you are put that one 0.0055 microfarad, you have to get it right. RF equals to 1.5 kilo ohm and R1 equals to 79.5 kilo ohm, and by CF equals to 0.0055 microfarad, and V peak to peak voltage equals to 1 volt. They have given 1 volt they have given. F equals to 1 kilohertz, it's a second one. V in equals to, this is the equation of Vp sine omega t. Omega equals to 2 pi f. Omega equals to 2 pi f. Vp is 1 volt. Sine of 2 pi f is 1 kilohertz into t into t. Yes, once again I am going to write that one. Vp equals to 1 volt, f equals to 1 kilohertz, Vin equals to formula Vp sin omega t, omega equals to 2 pi f, 1 into sin 2 pi 10 raised to 3 into t. Yes, is sin 2 pi V naught equals to V equals to, we have to write that V naught equals to, this is a V in, you got that one, RF C1 minus differentiation of V in divided by dt. V in divided by dt. RF is 1.5. Once again I am going to write that equation. V naught equals to minus RF C1 dV in by dt is a formula, minus RF is 1.5 kilo ohm, C is 10 raised to minus 7. Right, I'm going to use that one, plus 3 10 raised to minus 4. Right, then d of dt sine 2 pi 10 raised to 3 into t. Right, all minus sign it is there, minus 3 point minus 3 pi minus 3 pi cos 2 pi 10 raised to plus 3 into t. Minus 3 pi, it is minus 0.94 cos 2 pi 10 raised to plus 3 into t. Yes, I know if you are not getting that one, once again you have to sit it in your home, you have to solve it one by one. You have to get to know that one, how to solve this one. Yes, right, once again you have to see that one. Once again I'm going to explain about this one. V naught equals to minus RF C1 into dV in by dt. Correct. RF C1 is a 1.5 into 10 raised to minus 6 1 microfarad, and plus 3 is a minus 3. D of dt is sine 2 pi 10 raised to 3 into t. This 2 pi comes out 1.5 into 2 pi into 10 raised to plus 3. This plus 3 minus 3 get cancels. D of dt into, instead of d of dt, what it comes, cos of 2 pi 10 raised to 3 into t. This 1.5 into 2 pi, it is the minus sign, minus 1 it is there, minus 1 it is there, minus 4, minus 1 it is there, 0.94 cos 2 pi 10 raised to plus 3 into t. This is the answer. This is the answer comes is here. Right. Once again, you have to solve it in your home. If you are not getting that one, you can contact me. I will send the pictures of step by step. I'm going to tell that one. Right. Next is a Wien bridge oscillator. Wien bridge oscillator. Wien is the name of the scientist. Bridge oscillator. It is looking like a bridge. That is a oscillator. Is a oscillator. Light. Wien bridge oscillator is a simplicity and stability one of the most common used audio frequency. Yes, it is too fast, but I am going to explain about the Wien bridge oscillator is very important role it is there. Yes, it is the audio frequency oscillator. Is the Wien bridge oscillator in this figure? We have to see in that. Before going to study about this circuit, I am going to explain about the what is there in that. What is mean by the Wien bridge oscillator? A Wien bridge oscillator is a type of electronic oscillator that generates the sine wave. It can generate a large range of frequencies. It generates the large range of frequencies. What is the working principle of the Wien bridge oscillator? Wien bridge oscillator is a feedback circuit consisting of the series RC circuit connected with the parallel with the RC of the same components. Values producing the phase delay or the phase advantages of the circuit is depending upon the frequency at the resonant frequency F4 with a phase shift is 0 degree. If you are not getting that one, just leave it. Yes, first one is a Wien bridge oscillator. On Wien bridge oscillator is a type of the electronic oscillator that generates the sine wave. It doesn't generate the square, sawtooth, spike, or a triangular. It always generates a sine wave with a good peak, and it is a 0 degree phase shift. 0 degree phase shift means if you are giving the sine wave, its input with the signal, the same peak to peak are same. There is no any changes in the peak. That is the 0 degree shift. If you are understanding, I thought. Now I am going to study about the circuit. Yes, R1, R2, R3, R4 are the resistance. Wien bridge oscillator, which is the bridge circuit, is connected between the amplifier input. And one more thing I am going to tell that one. This circuit is an amplifier circuit. This is an amplifier circuit. And this circuit is a feedback circuit. This is a feedback circuit. One is a feedback circuit and one is a amplifier circuit. This is a pot. This is a pot of the resistance. Are you getting my point? Here. Right. The input terminal and the output terminal of the bridge has a series RC network. Series RC network is here. These are the one is a series and one is a parallel circuit. Has RC network one arm and the one arm is a series and another arm is a parallel RC network in the adjoining the arm in the remaining two arms are bridge registers R1 and RF. This is a R3 and the R4 are the bridge. R3 and the R4 are the bridges here. And the phase angle criterion for the oscillation is that total phase shift around a 0 degree. This condition occurs when the bridge is balanced. 0 degree phase shift ಇದ್ದರೆ ಅಂದರೆ ನಾವು ಏನು ಸೈನ್ ವೇವ್ ಕೊಡ್ತೀವಲ್ಲ ಅದೇ ಸೈನ್ ವೇವ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇದ್ದರೆ ಇಫ್ ಇಟ್ ಈಸ್ ದ ಸೈನ್ ವೇವ್ ಇಟ್ ಈಸ್ ಫಾರ್ಮಿಂಗ್ ದಟ್ ಈಸ್ ಅ 0 degree shift. When it is a 0 degree shift, it is the all the resistance values are equal. All the resistance values are equal, then only the phase shift except R4. R4 ಇರಬೇಕು ಅಂತ ಏನಿಲ್ಲ ಯಾಕಂದರೆ ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಅ ಪಾಟ್, it's a variable part. If you are adjusting the peak for that one, that's why we are putting that one. R3, R1 and R2 are all the resistance are same. And the balanced bridge it is there. The frequency of the oscillation F0 is exactly the resonant frequency of the balanced Wien bridge oscillator is given by 1 divided by 2 pi RC. All resistance values and capacitance values are the same. C1 equals to C2, R1 equals to R2 equals to R3. This is the balanced circuit of the Wien bridge oscillator. Right. What is the use of the Wien bridge oscillator? Wien bridge oscillator is used to find the unknown values of the components. To find out the unknown values of the components, in most cases the oscillator is used audios. Oscillators also designed simply, it is in the sine is compressed and it has a stable frequency output. I have already told that stability is one of the most common used in audio frequency. One of the most common is used in the audio frequencies, right? This is the usage of that one. This is a 0 degree phase. Why it is a 0 degree phase shift? If it is the bridge is balanced, then it is a 0 degree phase shift. The Wien bridge oscillators. So in the article, we will see the one of the more type of the RC oscillators. We know that one in the bridge oscillator. So Wien bridge oscillator is the harmonic oscillator. Harmonic, simple harmonic motion. Have you studied in that one? To and fro motion. The both the sine wave it is in the continuously it generates like that one. We can call it as a harmonic function oscillation, meaning that the output of the oscillation is the sinusoidal signal and it is used for the generation of the sine wave, typically in the range of audio frequency, typically in the use of audio frequency. So as you see here in these registers R3, R4 are the part of the amplifier. These two branches of the bridge circuit from the RC feedback network. This is a feedback network. This is a feedback network. That's why we can feedback network, we can call it as a, that's why it is a amplifier circuit, it is a feedback circuit, right? Then so here the op amp is used the non-inverting configuration and the positive feedback is provides to the op amp to the RC feedback circuit. Yes, it is an inverting terminal, right? Then, so now can we see the RC circuit consisting of the two RC networks. One is the series RC network and the another one is a parallel RC network. I have already explained. This is a series and this is a parallel. So here this is the series RC circuits are the high pass filter, while this is a parallel RC circuit is like a low pass filter. So the low frequencies, this capacitor acts like an open circuit. So it does not pass the low frequency signals on the other end at the high frequencies. This capacitor provides a very low impedances. Impedances means resistance is very low. So it is easy to allow the high frequencies. If the resistance values are very low, the frequencies are passes very fast. So so in a way it acts as a high pass filter. On the other end, you can see this is the parallel RC circuit is a low frequencies. This capacitor will act as an open circuit. It is an open circuit. So the output voltages in the series, it is in the high pass filter. In the parallel, it is in the low pass filter. Keep it in your mind. So the output voltage at this node will directly appears across this resistor R2, and the very high frequencies impedances of this capacitor will be very low. So the output will get the short circuited the grounded terminal. So in way parallel RC network is acts as a low pass filter. Yes, once again you have to read it thoroughly, then you can get to know that one what is the meaning of that one. Then F naught is equals to 1 divided by 2 pi RC equals to 0.159 divided by RC. AV equals to gain of the equals to 1 by B. B is referred to as a resistance. How many resistance are there? 3. It is a very low impedances. It is a reciprocal of that one is a R. By the gain of the equation of the inverting terminal is 1 plus RF by R1 equals to 3. Gain by the closed loop configuration. RF equals to 2 R1. Design the bridge oscillator. It is a sum of that one is design the Wien bridge oscillator. F naught equals to 965 Hz, C equals to 0.05 microfarad. Solution F naught equals to 1 by 2 pi RC. R equals to R they have not given that one. F naught they have given 3.3 kilo ohm. RF equals to 24 kilo ohm. By using which experiment? RF equals to how we can get to know that one. RF equals to 2R1. Just a minute, they have missed this one. R1 equals to 12 kilo ohm. R1 equals to 12 kilo ohm. RF equals to 12 into 2, 24 kilo ohm. That is in your circuit it is R4. It is the RF feedback resistance. RF equals to 24 kilo ohm. If you are not getting the 10 kilo ohm afterwards, the pot will get it in the 50 kilo ohm pot. You can use it for the 24 kilo ohms. If you get it, know that one, you can get the 50 kilo ohm pot, you can get it. If you are not getting that one, they may ask these questions for your exams. And this is also a Wien bridge oscillator is also there for your practicals. You can do the practicals also, the same circuit. The R1, R2 and R3 resistance are same. C1 and C2 values are, if you are taking equal. If you are not taking equal that one, if your peak will not comes correctly properly in the sine wave. If a zigzag will come and the sun peak will not balanced, that's why Wien bridge means it's a scientist named Wien, and the bridge is a balanced bridge. If you are doing that one, then only the oscillator the oscillates the oscillations, and you can get the output for that one. This is very important for that one for your exams. And the practicals also, they may ask the questions, practical questions also, viva questions they may comes for your practicals, right? So be carefully to draw this circuit. This is a oscillator circuit and the feedback circuit, and the feedback and everything will be, they can ask for your exams. Feedback and the sums, they can ask for the many sums on that one, these equations. Yes, you can closely be thorough with the subject, and you can get to know that one very easily. and you can practice it more on that one. Integrator and differentiator also you have to solve the more problems on that one. You can get to know that one, how to solve that one. This is the only one example they have given. R1 value I am not printing that one. R1 is a 12 kilo ohms. It 24 kilo ohms of the get to know that the feedback resistance. RF, R1, whatever that one. If you draw the circuit also, they can ask for that to draw the circuit. You can get the R values. R values means R1 equals to R2 equals to R. If you are R1 equals to R2 equals to R3 equals to, you can take it as a R. That is a 2 pi R. That is a 2 pi R. You can get that one. 1 by B means the total resistance, 3 resistance you have used that one. You can put that one. Then only you can get the values of that one. Then this formula is very important for your theoretical and practicals also. Yes, you have to throw with that one. Tomorrow class I am going to explain about the basic comparators and zero crossing detectors. You can use that one. Do attend the classes regularly, then only you can get that one. You can't understand without knowing that these two basics, and you can't understand that one. You have to go through this uh, classes regularly, attend that one. Okay, thank you.